Today, Mars is the prime example of an icy and hostile world. But that wasn't always the case. Billions of years ago, rivers, lakes, and even full-fledged oceans flowed across our red neighbor. As a result, the celestial body was also considered a potential haven for life. But what ultimately caused Mars to die? How did the planet lose its dense atmosphere and rich water resources? And did it even lose them at all? Well, not necessarily. Data from NASA's Mars Insight probe now suggests the revolutionary conclusion that the water on Mars has not actually disappeared, but is instead hidden deep beneath the surface. And the bottom line is that this means that real Martians could still be slumbering in the crust rock. So, be sure to stay tuned until the end if you want to know what fate befell Mars and why. Despite this, it could be much more alive than we thought. An extremely thin atmosphere that hardly deserved to be called as such. Freezing average temperatures of minus 60 degrees Celsius and a dust-dry surface covered with iron oxide. It's easy to see why Mars is often referred to as a dead planet these days. But if we turn back the clock 3.5 to 4 billion years, we are amazed to discover that Mars was completely different back then. During this phase, which experts refer to as the Noachian period, our now barren neighbor had a dense atmosphere, a strong magnetic field, stable temperatures, volcanic activity, and above all, water in abundance. And we're not talking about a few measly trickles, but full-fledged lakes, rivers, and probably even oceans. In other words, Mars resembled a certain planet Earth on which life was developing at around the same time. But as we know, the two celestial bodies then took slightly different paths. But why was that? How did Mars ultimately turn into a bitterly cold desert world? And how do we even know that it was once much more hospitable to life? Well, primarily because Mars is, after Earth, the best researched planet in the solar system. Since the 1960s, numerous probes have been sent to our reddish, shimmering neighbor, and 10 have even landed successfully on its surface. The rovers and landers are examining rocks, seismic activity, and chemical compositions at close range, giving us direct insight into the nature of the Martian soil, which is incredibly valuable for our understanding. But conversely, Mars sometimes returns a favor by providing us with informative samples. More specifically, this refers to meteorites that have been proven to originate from Mars and provide us with important information about the composition of the planet's mantle, traces of water weathering, and temperature and pressure conditions. What caused Mars to die? And so it is that our picture of the former Mars is becoming more and more comprehensive as time goes by. For example, 2 years ago, the Chinese Mars rover Zhurong found new evidence of the former existence of an ocean. According to this, until around 3.5 billion years ago, the northern lowlands of the planet were adorned by a shallow sea that may have covered up to 20% of the surface, roughly the same amount as the Atlantic Ocean on Earth. However, as we know, there is now no trace of the northern Martian Ocean, and the same applies to the rest of the red planet's water bodies. And researchers generally agree that the loss of the cool water was directly linked to the loss of the atmosphere. The prime suspect in this case is once again the solar wind, a continuous stream of electrically charged particles emanating from our host star. The bottom line is that solar wind is capable of tearing gas particles out of the atmosphere and catapulting them into the depths of space. The fact that we have not suffered a similar fate is thanks to the Earth's magnetic field, which protects us from the particle theft of solar wind. But this naturally raises a question of the extent to which our source of heat and life was actually responsible for the death of Mars. To clarify this, researchers led by Bruce Jakowski from the University of Colorado in Boulder recently examined data from NASA's MAVEN probe and the Mars rover Curiosity. More specifically, the experts focus their attention on traces of the noble gas argon that are present in today's Martian atmosphere, or rather in what remains of it. And this was no coincidence, of course, as argon is particularly well suited as an indicator of gas loss because it cannot be absorbed by rocks through chemical bonding processes. The scientific interests ultimately focus on the concentrations of two different argon isotopes, Since the lighter of the two is more likely to escape, more of the heavier isotope remained in the Martian atmosphere over the course of billions of years. Based on the accumulation of this heavy isotope, the researchers were able to draw conclusions about how much argon Mars has lost in the past. For their calculations, the researchers assumed a former ratio between the two isotopes similar to that in Earth's atmosphere. The findings on how strongly the solar wind robbed Mars of argon also provided insight into the loss of other atmospheric components such as carbon dioxide. As a greenhouse gas, this is likely to have played an essential role in the planet's habitable chapter. The bottom line was that around 2/3 of the argon that was originally present in the Martian atmosphere has been lost over time. The situation was very similar in the case of carbon dioxide, as most of this gas is also likely to have fallen victim to the effects of solar wind. Okay, but what about the magnetic field? Well, unfortunately, that has also been part of Mars's past for 4 billion years for the very simple reason that the planet's internal motor came to a standstill. A magnetic field is created when electrically conductive material is in motion in the liquid core. This happens constantly on Earth due to rotation, convection, and differences in temperature and composition. All these processes drive the geodynamic effect, the planet's natural electric power plant. However, since Mars is only about half the size of Earth, it also has a smaller volume in relation to its surface area. This meant that heat from the interior was lost more quickly, and convection in the core came to a halt at an early stage. As a result, the magnetic field probably collapsed within less than 100 million years after its formation, and the planet was left unprotected against solar radiation and solar wind. And as mentioned above, the atmosphere was blown away as a result, and this once life-friendly world was transformed into a barren desert. In the process, most of Mars's water was also snatched away into space. Well, at least that's what we thought until now. An underground ocean. Last year, researchers at the University of California in San Diego combined seismic data from NASA's InSight lander with a mathematical model of rock physics and discovered something truly incredible. On the one hand, the analyses confirmed that the average Martian crust is riddled with numerous cavities that make up more than 15% of the rock. And on the other hand, the data suggests that the cracks, fissures, and pores are filled with liquid water. The researchers say that a Martian crust made up of broken magmatic rock saturated with liquid water is the best way to explain the data they collected. To be fair, however, it should be mentioned that this sensational news currently has one small caveat. While it's true that a huge water reservoir could be hidden deep beneath the surface of Mars, this is only true if the research results are representative not only for the InSight location, but for the entire planet. But then, and this is the fascinating part, Mars could have a groundwater reserve in its deep rock pores that extends across the entire celestial body. In detail, the calculations show that the middle crust contains enough water for a global ocean that would flood the entire surface of Mars to a depth of 1 to 2 kilometers. In this case, the planet would not have lost its water to space through atmospheric outgassing at all. It would simply have been displaced. In other words, most of the water that once existed on Mars seeped into the depths of the planet's crust, where it has remained in the form of poor water ever since. At the same time, however, the hidden water reservoir is also considered a place where life may once have existed or even still exists. There is no doubt that the underground home of the potential Martians would then be an absolutely extreme world. But it's also undisputed that there are indeed microbes on Earth that can withstand even the most adverse conditions. And while the black smokers at the bottom of the deep sea are sometimes even suspected of having made the development of life on Earth possible in the first place, the inhabitants of the so-called deep biosphere are also true survivalists. The Earth's basement dwellers mainly take the form of bacteria, viruses, and fungi, which thrive not only in ocean sediments, but also in volcanic rock and even in the bedrock of the continents kilometers below the surface. And true to the motto, what works here can also work elsewhere, study co-author Michael Mangus sums it up as follows. Quote, Since water is a prerequisite for life as we know it, I don't see why the underground reservoir of Mars shouldn't be a life-friendly environment. We haven't yet discovered any evidence of life on Mars, but we now at least have a place that would allow life in principle. And we have a place that would allow a subscription in principle. Just click the thumbs up and subscribe now to never miss a new video from us again. See you soon.